Hello and welcome to Rust Programming Language Full Course for Beginners. In this course, I've put all of my effort to teach you everything you need to know, explaining the core concepts and the principles ruling Rust language so you can start programming in no time. And before we get started, I hope you're finding these tutorials and courses helpful. I love creating these resources and sharing them with you all for free. If you have found value in my work and would like to help keep this content accessible for everyone, you can join our community on Patreon or simply buy me a coffee to keep me fueled. Thanks for being part of our learning community. With that out of the way, let's go ahead and start our course. The first question you might be thinking of is, what is Rust? Rust is simply a systems programming language like C and C++, used for building operating systems or game engines, which means that it's a compiled programming language. Compiled programming language simply means that the language itself uses a compiler, some sort of dynamo or machine that translates what you write into machine code so your computer will understand and translates into different actions. Rust actually has started as a side project by Graydon Hoare in 2007. He named it after the rust fungus, and then it was sponsored by Mozilla Company in 2009. But the first version of Rust has appeared in 2014. Now, for some reason, Rust programming language has been the most admired language for 7 consecutive years, according to Stack Overflow Developers Survey. You can see here it says that Rust is the most admired language. More than 80% of developers that use it want to use it again next year. To be exact, it's 86.1% of 65,000 developers voted for Rust as a language that they want to use again next year. And those who get the opportunity to use Rust have fallen in love with it. Compare this to something like MATLAB. Less than 20% of developers who use this language want to use it again next year. Only less than 20%. In contrast to Rust, where more than 80% of developers want to use it again next year. And you can see that JavaScript, Python, TypeScript, HTML, CSS, SQL, and Rust. But do not be fooled because we are judging by this red circle. And you see that Rust's red circle is winning by a big margin. And some of the biggest companies in the world actually are using Rust, like Dropbox, Discord, Go, NPM, Amazon, Mozilla, Facebook, and Microsoft, just to name a few. That's great and all, but we want to know what is the secret behind Rust. Why do developers love it and companies prefer it over other languages such as C and C++? And believe it or not, the White House actually has suggested that companies must switch from C and C++ to Rust programming language. That was a few months ago in February. It turned out that the reasons behind that love to Rust, and remember that Rust is a systems programming language like C and C++. The secret here is that Rust tries to do what's being very hard and difficult for a lot of programming languages, which is finding the balance between speed, safety, concurrency, and portability. If we'll talk about speed, Rust is fairly comparable to C and C++ in terms of speed. C and C++ are low-level programming languages that execute in no time. They are very close to machine code and they're so close to your metal, to your hardware, because the compilation between C and C++ to machine code is blazingly fast. Rust is actually comparable to that speed. Number 2, safety. Most of the low-level programming languages like C and C++ are very fast in compiling to machine code, but with that speed comes unsafety. They are not particularly safe, and when I talk about safety, I mean safety in memory management. And don't worry, we're going to talk about safety in details throughout this course. Number 3, concurrency, which means multi-threads can run in parallel if you decided to design your application this way. Sure, there are bugs like data races and dangling reference errors, which I will explain in details in this course. And finally, portability. This is where we say that you can compile once and run everywhere. You turn or you compile your Rust file into an executable file, which is going to be portable throughout all the other systems. Whether it's Windows, Linux, or Mac, you can be sure that your program is going to work on those systems. So for example, you have high-level languages like Python. It provides garbage collection for better memory management control. And don't worry about those terms, I'm going to explain that in details when we reach the ownership chapter of this course. And then you get low-level languages like C, providing functions for memory allocation. But it turned out that those functions are not the best solution for memory management. Now Rust doesn't have garbage collection, nor it has functions for memory allocation. Instead, Rust uses a concept called ownership and borrowing. This is going to be discussed in details in chapter 4 and 5. Rust also has a package manager called Cargo, and Cargo is similar to npm for Node or pip for Python. Now let me show you Rust website, how we can install Rust very easily, and I will show you how we can print first hello world program using a simple file and also using Cargo to create our first project. Alright guys, so what you need to do is to go to your browser and type rust-lang.org and you will find this page. And here you will find everything you need to know about Rust, so it's a language empowering everyone to build reliable and efficient software. Why Rust? Because of the performance, reliability, and productivity. Down here below, build it in Rust, so you have here some building tools like command line interface, WebAssembly, networking, or embedded. If you like this low-level control through semi-hosting, panicking and all that kind of stuff, working with the hardware, no problem there. Rust is going to help you. Next, we have Rust in production. So you have here hundreds of companies around the world are using Rust in production today for fast, low-resource, cross-platform solutions. npm is using Rust, as we said, Yelp, so you can get involved, you can read Rust, that's your main resource. So this is very important. You can read Rust, watch Rust, and contribute to the code because it's an open source project. Also, this is very important. The Rust book is your guide, your friend while learning Rust programming language. The documentation, so you have here the standard library, edition guide, Cargo book. So you have here everything has a book. So Rust C, that's the compiler. You can read that and familiarize yourself with the knobs available in the Rust compiler. You can read for Cargo for the package manager. This is edition guide, so for the guide to the Rust editions. The standard library, that's very important also, that shows you everything from the macros, the modules, the functions, and everything you can search for inside the standard library. Build your skills in an application domain, so command line book, WebAssembly, and embedded. So they have everything in that website, but what we're interested here now is to install Rust on our local machine. So you will click on install, so you have install Rust using Rust up, so that's the recommended way. If you're working with Linux or Mac, you can just copy that curl link and paste it to install, or even if you're working with Windows subsystem for Linux, you can do the same thing. Otherwise, you can go and download the rustup int.exe. You will run that and everything will be fine. It's going to be installed in no time. It's very easy to install the rustup. Once it's installed, let's go now and check out if we have Rust installed or not. So if you will do rustup -- version, and you can find here that it says rustup version 1.27.0. It also tells you here that the currently active Rust C version is Rust C 1.77.1. To verify that Rust compiler also has been installed successfully, you can do Rust C -- version, and there we go, we have 1.77.1. Also, you can check out Cargo, so you can do Cargo -- version, and we have also Cargo version 1.77.1. Alright you guys, so I want to show you how we can print a simple hello world program in our terminal. So I will create a folder and I will call it Rust Hello, and I'm going to cd to that, Rust Hello, and I'm going to open this with Visual Studio Code by typing code space dot to open Visual Studio Code inside that current folder, inside that current directory. Just hit enter and Visual Studio Code should be open to you. I'm going just to bring it over here. And the first thing that you would want to do inside your folder is to create a file. I'm going to create this file hello.rs. RS is the extension for Rust programming language. I'm going to hit enter, and there we have our first code line in Rust. So the main entry point in your Rust file is main function. To define a function, simply you will type fn and the name of that function. It should be main. Followed main, we will have parentheses. Now you do that. So you will get outside of the parentheses and you will open curly braces. Inside the curly braces, you would want to print hello world. If you're familiar with languages like Python or JavaScript, in Python you would do print and then you will pass the string of the letters that you want to print to the console. In JavaScript you would do console log for node and so on. Verb. Print line with an exclamation mark followed by parentheses, and then inside the parentheses, starting by those double strings, inside the double strings, we will have whatever the words that we want to print to the console. Now I will hit Ctrl S to save my file. I will open my integrated terminal by hitting Ctrl and tilde. And then what you want to do here is to type simply Rust C, which stands for Rust compiler, followed by space and the name of your file. In our case, our file is called hello.rs, so we will need to type hello.rs. If you will hit enter, notice that nothing actually has happened. Why is that? If you will come here to the Explorer, you will find that the Rust compiler actually has compiled your Rust to an executable file, which is hello.exe. This is invisible, of course, because it is zeros and ones. As a matter of fact, you don't have to see it. The most important thing is that Rust has compiled your Rust file with no problems, with no compiling errors. What you want to do now is to run that executable. So if you will come back here, if you will do /hello and hit enter, you will get hello world printed to you with no problems. Now there is another way to do that using Cargo Package Manager. To do this simply, we want to use Cargo to initialize a project. So what you want to type is Cargo new and the name of the project. Let's call this project Hello Project, for instance. Notice here that created binary application, which means that no problem there, Cargo has created your Hello Project folder. Inside the Hello project, we have different files and a folder called source. Cargo.toml for the settings for your project. You see here the name, the version, and the edition. And if you want to add some dependencies for your specific project. Also, you will have .gitignore. Inside the source, the main file is main.rs. And notice that it has the same exact main function that we have manually typed in the last example. Let's actually change that. Let's say hello Rust from Cargo, and I will hit Ctrl S to save. And what you want to do is to change directory to hello project folder. And now you're ready to run your project by typing a simple command, which is cargo run. You will hit enter, it compiled, and you can find here that hello Rust from Cargo. Now let's say, for example, that I want to change in that hello Rust from Cargo, and I want to add, for instance, instead of Rust, I will add a crab. If I will hit Ctrl S, and if I will do cargo run again, now you can see that hello and the crab from Cargo has been applied directly. Now let me show you something very interesting and you need to be aware of. Let me show you if we will go to our file that we have created, which is hello.rs. And I'll click on hello.rs. And if I want to change hello world to hello crab. Now let's do Ctrl S to save. And let's do /hello. Hit enter. You'll find that nothing actually has changed. And that's because you have to compile your code every time you do changes. So you would use Rust C again to compile the hello.rs in order to apply the changes. And now if you will do dot/low, you will find that the crab has appeared and the changes has been applied. That's a very important point when you create manual files not in projects. The project itself compiles every time you do cargo run. But in the simple applications written in Rust files like we have done here manually, we have written the main function manually, you need to use the Rust compiler after every time you make some changes. And that's it for the introduction for Rust programming language. Thank you so much for watching. In the next part, we're going to study primitive data types. Hey, what's going on? My name is Amir and this is BekBrace channel. Today we are going to study together the primitive data types in Rust programming language. As you know, Rust is statically typed programming language, which means that you need to define the data type of the variable you're declaring. The primitive data types are also called scalar data types, like the int, the float, the boolean value, and the char. These are the primitive data types. So let's take each one independently. Let's take together the integer. So Rust has signed and unsigned types of different sizes. The signed, which means it could be plus or minus, they are i8, i16, i32, i64, i128. These are signed integers, could be plus or could be minus. They can hold positive values or negative values. However, the unsigned integers hold only positive values. They are u8, u16, u32, and so on. So let's take a look to an example together. We'll create the main function. And I will have x. And x is going to be of data type i32. I'm going to explain to you what is i32, what's the difference between 8, 16, 32, 64. For example, we'll take the difference between those, but the concept is the same. Basically, the main difference lies in the size and the range of the values they can represent. So the smaller the number, the smaller the size and range they can have, and the bigger the number, the bigger the size and range they have. This is in brief, but I will talk a little bit about that in a moment. So x is going to hold value of 42, so it's i32. This can be, by the way, negative. It's okay. And also we can have y, and this variable is of data type u64, for instance, but in this case it should only hold a positive value, okay, because it's u. Okay, it could be u32, u64, whatever. And let's print together. I'll say signed integer, and this is the placeholder. And here I want the x, and the same for the y. So here unsigned integer, and we want the y. Let's take a look. Okay, now we have the executable file. Let's run the main, and we'll have signed integer minus 42 and unsigned integer 100. What will happen if I will put in the positive value a negative value here? Let's do rust c main rs again, and we have a compiling error. Let's take a look what the compiler says. It says here cannot apply unary operator minus to type u64. Okay, that demonstrates what we're saying. So let's remove that. Let's save, run again. Basically, the i32, it can take 32 bits of data, and this here can take 64 bits of data. But what else? The range. The range for the i32 can vary from 2 to the power of 31 in a negative value to 2 to the power of 31 in positive value. While the i64 from 2 or minus 2 to the power of 63 to positive 2 to the power of 63. And let's take a look quickly. So let's say let e have 32 with the maximum value of, let's take this one, okay, And also, let's do here for the 64. And both of them are the largest positive values. More than that, you will have a compiling error. And we have printed everything. So let's go ahead and check that out. Let's compile everything. So good. We don't have any compiling errors. Good. Maximum value of I32 and maximum value of I64. What will happen if we'll increase this, for example, by 9? And here we'll increase it to 8. Save that. Run again. And we have a compiling error. We have the literal, this number does not fit into the type I32, whose range is this. So this is the maximum, okay? And the same case goes here. We have changed to 9, while the maximum should be to 7. And it says here that consider using U32 and U64. The main difference, actually the U32 and U64 are a bit larger than the I32 and I64, but not by much. Okay, it's just the compiler is suggesting what you can do in this case. If you have more number of bits to be allocated to a certain variable, but in case that it's not fitting to that data type, you should change the data type, or you should consider using a larger data type. In this case, it could be the I128, for instance, if I64 is not enough. So U64 and U32 are larger. The whole thing actually from U8 to U28 are a bit larger than the I8 to I128. And that has to do with the power. So if the I is 2 to the power of 63, U is 2 to the power of 64. Okay, so that's as far as the integers. Let's go now and take a look to floats. The floats simply represent numbers with fractional parts. I think you know what a float is. So we have only two. We have F32 and F64. These are the floating point types that we have in Rust. And now let's take an example. So let's create the famous pi. That's going to be of data type F64. That's going to be 3.14. And let's print that, and we'll say value of pi. Okay, let's take a look. Okay, and we don't have any problems. Value of pi 3.14. Next we have the Boolean values. So Boolean values, as you know, are whether true or false. So let's have an example. Let is snowing of data type bool, that's the data type BOOL, equals to true. And be careful, true is not capitalized. I mean the T is not capitalized. Don't forget the semicolon. And let's do print line. I'll say here, is it snowing? And we'll pass here is snowing. All right, let's run that. Okay, we didn't have any compiling errors. Is it snowing? True. And finally, we have the char, or the character type. And the character type actually represents a single Unicode scalar value. Okay, so that's a Unicode character type. So for instance, letter X, letter Z, you know, whatever it can be. So I'm going to declare a variable called letter, and I'm going to define the data type to be char for that variable. And I'm going to assign a value to this A in single quotation. And now let's print that line. And let's say first letter of the alphabet, for example, is, and we'll pass the letter. All right, let's do Rust main.rs. We didn't have any compiling errors. Good. Main. And we have first letter of the alphabet A. Okay, that simply sums it up. These are the 4 data types or the 4 primitive data types that we have in Rust. Thank you, and I will see you in the next lesson. Hello guys, this is Amir from BekBrace, and in this lesson we're going to study the compound data types. So the compound data types in Rust are categorized into 4 groups: the arrays, the tuples, the slices, and strings, and also the slice string. Arrays are a fixed size collection of elements of the same type, of homogeneous types. So if you have integers, you need to have an array only of integers. If you have strings, you need to have an array only of strings. I'm going to declare a variable. The numbers are going to hold an array of 5 numbers: 1, 2, 3, 4, and 5. So of course we can leave it like that, but in Rust, as we said, this is a static type programming language, so we'll need to define the data type of the variable that you are declaring. So numbers, we're going to give it a data type of i32, and this is going to be inside brackets, like that, square brackets. So i32, then semicolon, because we need a second parameter. The second parameter here, or the second type of data, is the size of the array. So as we have 5 numbers, then the size of array is naturally going to be 5. So we'll do print ln. I'll do like this, and we can say number array, and we need a placeholder, and deliberately I'm going to leave it like that. I know that we'll get an error, but I want to show you the error message. And do not forget the numbers variable. All right, so let's go ahead and run our application. So say rustc main.rs, and there we go. We have here i32 cannot be formatted with the default formatter. So the main problem is in the curly braces. In Rust, we have 2 types of formats. We have debuggable and display. So debuggable format and display format. And I'm going to explain that in detail in the next lessons. But for now, let's fix that by putting colon and question mark. So let's run that again. And we didn't get any errors. So we have our executable, perfect. Let's go ahead and run our main file. And we have number array 1, 2, 3, 4, 5. So what will happen if I will change a little bit in that? So we'll say, for example, mix. I know that's going to be wrong, but just to show you. So mix, we can say 1, 2, we can say here, for instance, apple. We can say true, and close that with semicolon, and let's print that, print ln. Let's run that again. And of course we have an error, expected integer found string slice, because we said that any array should contain the same data type inside it, homogeneous data types. So this is going just to comment these lines out, and let's get the last example for the arrays. So let's say, for instance, that we want fruits. In this case, we would want string or string slice. I'm going to explain the difference between string and string slice in a bit. But just bear with me to do that. We're going to have this ampersand str. That's not a string per se. This is a reference to a string. So as we did for the numbers, we're going to separate that with semicolon, and we'll need the size of the array. I'm going to give it apple, banana, and orange. Fruits array. Of course, we can return all the fruits, but also we can return some indexes. So how to do that? In this case, I'm going to leave it like this, and we're going to return the first element, which is apple. And let's do 1 and 2 as well. All right, so these are the first, second, and third elements plus the whole array. Let's go ahead and try that out. Now let's go ahead and run our file. And as expected, we have the fruits array, the whole array, apple, banana, orange, then the first element, second element, and third element. Next, we will explain tuples. So tuples contain heterogeneous collection of elements of fixed size. So what we have done here by adding one or integers, strings, and Boolean types, we can do it in tuple. But instead of those square brackets, we're going to put it inside parentheses. Let me declare a variable. I'm gonna call it human inside parentheses. Alice, so that's a name, string rather, 30, which is an integer, and true, let's make it false. So this is a human variable. You can leave it like that, or even you can do like this. You can actually set the data type of each element. So Alice is a string, 30 is I32, and false is bool. So either way, it's going to work. Print ln, open parentheses, double quotes, and we'll say human tuple, and inside curly braces, we'll have also the colon and question mark, and we're going to pass the human here. All right, so let's go ahead and run that. First, let's compile. We have an error because Rust was expecting a string. Instead, it got a string slice. So I'm going to explain the string and string slice in a bit. But for now, let's just convert that. By the way, if you delete that, look, if you delete that, it should run okay. And we'll display everything. We have Alice 30 and false. The problem was caused because I've defined here a string. So this here, this is not a string. To convert that to a string, we need a special function called to_string. So this is going to convert this string slice to string data type. So let's just compile that again, and we didn't get any errors as expected. Run, and we'll have the same exact result. All right, this is going to be very clear to you when I will explain to you what's the difference between string and string slice. We can also have a mix tuple. So let's declare another tuple. I'm gonna call it my_mix_tuple. And this my_mix tuple is going to have different data types. Again, you can do like we have done here, just determine each data type of each element in your tuple, or I'm going to just leave it like that. So we'll have string Kratos, that's just the name, 23, that's integer, true, that's boolean, and even you can have a different data type, different compound data type like arrays. So let's try to put an array here. 1, 2, 3, 4, 5. Okay, and let me try to print that. We'll say my mix tuple, and of course we want this debuggable format like this, and we will pass my mix tuple. All right, let's go ahead and try that. Perfect, we didn't have any compiling errors. And take a look at that. My mix tuple variable has returned everything, including the array. Okay, so we have string, integer, boolean, and array inside the tuple. Now let's move on to our third compound data type, which is called slices. So slices simply are dynamically sized view into a contiguous sequence of elements. In computer science, and specifically in programming, contiguous sequence of elements is a very well-known term, especially when it comes to memory. Let's say we have this array here. We have 1, 2, 3, 4, and 5. So contiguous means uninterrupted, okay? Adjacent to one another. So when displaying something in a contiguous sequence form like an array, the memory doesn't have to jump between memories, but rather going one next to 2, element 2, the third element, the fourth element, the fifth element, they are all next to each other. And this is a very good thing for memory allocation and memory efficiency, of course. Let me give you an example about slices. So I'm going to declare a variable. I'm going to call it number slices. And that's going to be the exact same idea of string slice. We will have this ampersand. So ampersand in front of this array of 1, 2, 3, 4, 5. We can leave it like that, but I prefer to determine the data type of that variable. So I'm going to add a another ampersand, and inside brackets, we'll determine this as I32. We have a number slice. This number slice has an array. In front of it, we have this ampersand, but also the I32 as primitive data type has in front of it this ampersand. So let's try to print that. Now let's compile that. We didn't get any errors, good. And we have number slice 1, 2, 3, 4, 5 as expected. Let me give you other examples for slices. So we can have, for instance, we can have animals slices or animal slices, and that's going to have a different data type. It's going to be a string slice. So it's not going to be a slice, but string slice is a reference to a string somewhere in your code. I'm going to explain the difference in a moment. So we have this as stir, and instead of 1, 2, 3, 4, 5, we'll have different animals. We'll have lion, elephant, and crocodile. And I want also to change this a little bit. So let me just change that animal slice. And we'll have here animal slices. And finally, I want to have book slices. Here, I want a string and not a string slice or a reference string. So in this case, string, be careful, has a capitalized S. And we'll do the same thing as we have done here for human. So we have defined a string data type of Alice, and we have used the toString function. I'm going to do the same thing. It looks a bit bizarre, I know, but this is valid code. Let's go ahead and compile that. Good, we didn't have any errors. Let's check out what we'll have. Good, and as expected, we have here the number slice, 1, 2, 3, 4, 5, the animal slice, lion, elephant, crocodile, book slice, you know, the books. Now, speaking of strings and string slices, let's go ahead and check out the last data type inside the compound data types. The main difference between strings and the string slices is that the strings are growable, which means expandable. You can increase them or decrease them if you want, and hence they are mutable. So you can push and delete data from a certain variable if you want, and they are owned string types. Owned means that they are not borrowed, and I'm going to talk in details in a separate video about the concept of borrowing and ownership in Rust. And you need to know that memory allocation and memory efficiency is very important in Rust programming language. Rust basically is like C and C++, but much better. It has the best of all worlds from C and C++, as it's, you know, C and C++ are low-level languages. They are very fast because they're very close to your hardware, to your metal. C and C++ compile to machine code in no time. Rust actually does the same thing, but with no garbage collection and automatic memory management. When you declare a variable which is a string, actually, it's going to be allocated on the heap. And there is a difference between the heap and stack, and I'm going to talk about later. So they're actually allocated on the heap, and then these string objects can grow or shrink in size as needed dynamically. It's not fixed, but dynamic. It can grow, it can shrink, you know, you can add to it, you can delete from it. So this is done at the runtime in the background. So the memory allocation is made dynamically in the heap, but that's actually very slow to access because, you know, it's not fixed. It's wide, it's big, and it's slow actually when you have a lot of strings allocated and stored in the heap. But they are very useful because sometimes you want to modify your own string data dynamically, and that's your only choice basically. All right, so we spoke a lot about string. Let me give you an example. So you need to know that any data type in Rust by default is immutable, which means that you cannot change it. So if I'm going to declare a string variable, I'm going to give it the name of stone cold, and stone cold is of type string, okay? And that's going to be equal to string from, and we're going to say here, for instance, hell. Let me just try to print that. So print ln, let's say stone cold says, and we're going to pass here stone cold. All right, let's compile that. Oops, I forgot to have the placeholders. Okay, good. And we'll have stone cold says hell. Now, this stone cold variable is stored on the heap memory. Both the heap and the stack are the memory, okay? Just for you to not be confused. But I want to show you if you want to expand in that variable stone cold. What we can do, we can say stone cold dot a method called push underscore stir, open parentheses, double quotes, and we'll say here, yeah. All right, but as I told you that all of the variables in Rust language are immutable by default, you need to add the keyword mute before the variable here. So now you have converted this variable from an immutable data type to a mutable data type, and then you can do push string to add another word to your original data. All right, and before trying that, let me just put this here down. So let's run that again, and here we go. Stone cold says hell yeah. So we successfully have added or pushed to that variable a new word. So this is the string. It's mutable, it's ungrowable, it's an own string stored on the heap, unlike the string slice, which is stored on the stack. So this ampersand stir is a string slice, which is a reference, okay? This is not an own string. This is a reference to a portion of a string that it's stored somewhere in your code. They're also immutable, which means that you cannot modify anything. The string slices are used to reference string literals or substrings of string objects without needing to copy or own the data. So this is very good for memory efficiency because you do not have to copy the same variable. So these string slices are used when you want to work with string data without taking ownership of it. They also have specific size and no number of bytes to the stack. So the stack remembers that very well and reacts very quickly in contrast to the heap, which is expandable and, dynamic. It goes at the runtime in the background and can grow bigger and bigger and bigger and can be slower and slower. So that's the main difference between the heap and the stack. The stack is quicker, the heap is slower. But the stack can't have any mutable data types, while the heap can have dynamic mutable data types. So let me declare a variable here. I'm gonna call it string, okay? And this string has a data type of string written like that. So type string from, and we'll say here hell, or let's do hello world, okay? Now I want to declare a slice. So this is going to be a string slice actually. So say slice with the ampersand stir, and that's going to be equal to ampersand string. And as you can see that this slice is actually referring to the string. We haven't copied the value of hello world. So if this has a specific number of bytes, that's not going to be copied entirely. It's going to be only referred to the value that it's inside that string variable. Okay, we can leave it like that. Slice value and save. Okay, good. And we have slice value hello world. You can also determine what you want. So with the index, so if we want, for example, 1, 2, so 0, 1, 2, 3, 4, so we can say 0 to 5. Okay. And there we go, slice value, hello, only because we have, defined the number of characters that we want to return. One last thing that I want to mention here is that Rust cleans any memory allocated to any variable. So if you will try to display that slice outside here, you will get an error. It will yell at you, telling you that it's out of scope and it's undetermined. We don't know what is slice. Function, hello, or maybe print. And simply we're going to print ln and we're going to do like that. Slice, here we want the slice. Now take a look. When we will compile, we will have an error, not found in this scope, right? Cannot find value slice in this scope. And with that, thank you so much for watching. If you're new to the channel, please don't forget to subscribe and hit that notification bell to get notifications for our future videos. Thank you, and I will see you in the next video. Hello and welcome back. In this part, we're going to study functions in Rust. So up until now, we have only seen one function, which is the main function. So when you will go to your projects folder, then you will type cargo run main.rs. You should see hello world after the compilation. Now you need to know that this function right here, this main function, is your entry point. So if you try to change the name of the function, for example, let's say hello, immediately you'll find that you have two types of errors, these squiggly lines. The first one says function hello is never used. And that's because Rust expects that this hello function is going to be inside the main function, to be displayed inside the main function. That's why Rust doesn't understand what the hell is going on. There is only one hello function, but there is no main function. And this is going to be very clear when you will hover over here. Main function not found in grade_3 functions. This is the name of our project. So if you will try to run this function, you will find the same exact error message. The error E0601, main function not found in grade, and the name of your project. You should always have your main function, as this is the entry point, and immediately the Rust analyzer displays the run debug button here. It does the same thing. When you will click on that, it compiles and runs the code. So any function in Rust starts with the keyword fn, followed by the name of your function. If we're not talking about the main function, if any other function you're going to write, it should start by the reserved word in Rust fn, which stands for function, of course. And then following that, the name of your function, parentheses, curly braces, and then you will have the body of your code here. Also, one very important point, any function or variables for that matter should be written in snake case. Snake case should have all letters in small and separated by an underscore. So let's say that we want to create a function that says hello world. It should be written like so. This is the snake case. Also, there is what we call the kebab case, and that's simply hello, but separated by a hyphen, and kebab because this looks like skewer between two pieces of meat. The main recommendation is to write your functions and variable names using snake case and not kebab case. Let's say that we want to create a different function. So let's create the one that we just talked about, hello_world. Of course, inside parentheses, you can have different parameters. You can set your parameters here, but we don't need that. And then you will print line, say here, hello Rust. And here Rust is complaining because this function is not used. So we're going to delete that and we're going to pass this function here. So hello world, we're going to pass it here. And yeah, that's simply it. Do Control L. So if you run that, you should get hello Rust with the crap. Okay. Notice here that I've written the function below the main function. This is not available in all programming languages. You should define your function first and then call it afterwards. In programming, this is called hoisting, where you can actually define your function above or below, and then you can call it anywhere in your code. Hoisting also exists in JavaScript, by the way. We can also insert input values, right? We can insert parameters and then pass the arguments when we call the function. So you can insert input values. So let's say that we want to create a function that tells the height simply. So let me call this function tell_height. And in parentheses, I'm going to have the height, and it's going to have data type of integer 32 bits. Then I will say my height is open close curly braces, and then we're going to pass the height. Again, we can go above here and call this function. So I'm going to call the tell_height function, and the height that you can see immediately that Trust is making things easier for you. So it tells you that you need to insert your argument here, which is height of data type i32. So I'm going to pass just an arbitrary number. So I'm going to pass 182. That's an integer of 32 bits data type. Or you can do it u32 because this is unsigned. So the height should be always positive. Close that with a semicolon. Control-L to clear the terminal. Cargo run main.rs, and my height is 82. Can do it just like that. Centimeters. Can compile it one more time. All right. So let's create a function together. Fn human_id, and inside here I'm going to set different parameters for this function. So the first parameter is going to be the name, and that's going to be of data type &stir, which is a string slice. I've explained the string slice in the last video. Please go ahead and check it out if you're not sure what is the string slice and the difference between the string slice and strings. Also, the age, I'm going to set it to u32. Also, we can have a height. I can make it f32, floating point. Okay, we can have some decimal points here. Open close curly brace. And again, I'm going to print ln. I'm going to say simply my name is placeholder. I am another placeholder, years old, and my height is whatever centimeters. And then we're going to just declare those parameters. We have a name, we have an age, and we have the height. And don't forget to close that with a semicolon. Okay, so this is the human ID, and if we'll go ahead and pass that human ID here, human ID, you can see immediately that we need to pass different arguments, the name, the age, and the height. So let me pass first, that's going to be a string slice. So I'm going to type Joel, that's the name. The age is going to be 55 without double quotation. And then the height is going to be floating points, so 182.3, for example. All right, if you will leave it like that, you will get an error. You can see that squiggle line here, and it will tell you that use a float literal. If you want to leave it at 182, you can do 182.0. You can leave it like that. Okay. So let's go ahead and run our code and see how it will compile. So it compiled without problems. My name is Joel, I'm 55 years old, and my height is 182.2. So like any other programming language, Rust's function can return a value. So functions do not only print lines, but they can actually return value. So we can do mathematical operations, and the result of that function is going to be whatever that mathematical operation will evaluate to. But before that, I will need to talk a little bit about expressions and statements, because this is a big deal in, well, any other programming language, but as we're talking about Rust. So what is an expression and what is a statement? Simply put, an expression is anything that returns a value, and a statement, that's anything that does not return a value. So let me give you examples on expression first. Expressions could be any number, for instance. So 5 is considered to be an expression. Boolean values are considered to be expressions. A function that it will evaluate to something, so add, let's say 3 and 5 or 3 and 4, whatever. This is considered to be an expression. The F conditions, so the control flow, actually all of the F condition and else is considered to be expressions. So if condition, and here whatever value 1, for instance, else value 2. So all of these are considered to be expressions in Rust. So again, expression, anything that returns a value. Also, expressions can include blocks, the curly braces. Blocks are very important like in any other programming language. So here, whatever is from code inside this code block. So let me actually give you an example. If you will try to, so this is the main function. If you will try to declare a variable here, let x equal to, and you open your code block. So here is your code. You'll find that Rust doesn't like this idea. Why? Because simply Rust asks you to consider using const or static keywords instead of let for global variables. So any variable that is declared outside of the main function should be declared with the const keyword. Now we won't have any problems. Only you will have minor problems, so the x should be actually defined in capital letters. Let me just show you. So const x should have uppercase names, so x like that. So you can simply do underscore x, but that's not enough because we need to close this with semicolon and we should enter a value. Okay, but I'm not going to do that. I want to declare this variable with let keyword. So let me just enter the main function and let's do it here. So let's say that I want to create this expression x like that, which is going to be equal to different variables inside. So x will have a price, which is equal to 5. It's going to have also quantity, which is going to be an arbitrary number, let's say 10. And we want to display the result of the price multiplied by the quantity. Okay, so we want the evaluation of the price multiplied by the quantity. Notice that this is the last line in this expression. Notice that this last line, I haven't written here any semicolons. Okay, here I should. Why is that? Simply because any expression that evaluates to a certain value, a certain mathematical operation, will evaluate to the last line in that expression. So if you will leave it like that, price multiplied by quantity, automatically it's going to evaluate to 50. So this is a very unique feature in Rust. Alternatively, you can do like that. You can do return price multiplied by quantity and you can close it with the semicolon. But you know, that's not very, Rusty. Yeah, and again, we can do like that. So this is it simply. You have a code block, you have some variables, you have a mathematical operation that evaluates to a certain number, and then simply you can pass this variable. So let's say, for instance, that we want to print the value of that. So print line, then we're going to say result is like that, and let's actually compile the code. And you can see here that the result evaluates to 50 as expected. Also, functions return values. Let's say, for instance, that we have a function that adds two numbers. The first number is going to be i32 of data type i32. It's going to be parameter A. We have a second parameter, which is b, i32. But this function that will return a value should have this arrow like that and should determine the data type that we want to return, or that we want this function to return. And then in the body of the function, we're going to add a plus b. Notice that I haven't done like that, like done here in this variable, right? We are going to leave it like we have done with the price and quantity. We're going to leave it without the semicolon. Okay, so this function is going to evaluate automatically to whatever numbers are going to be passed as arguments when we're going to invoke this function in the main function. So let's actually invoke that function. So what was it called? Add. So we'll do add, and we're going to pass two numbers. The first one of type i32, let's say 4, and the second one, let's say 6. Okay, so this is A and B. So I'm going to show you something that's interesting. You can actually do like this, let y equal to add. So this is your add function. So you can do like this. So basically you can, I'm gonna copy that. I'm going to just paste that here. Okay. And now what you have done is that you have assigned this function with the arguments 4 and 6 to a variable called y. So you can print that, print ln, okay? And let's just clear the terminal. Let's run that again. And you can find value of y is 10, which is the sum of 4 and 6. All right, so alternatively, what you can do is print ln, and you can say value from function add is, and open close curly braces, just full stop like that, and we'll invoke that function, close parentheses 4 and 6, and now let's go ahead and run that, and you can find here that the exact same result. Value of y is 10, value from function add is 10. Okay, so these are expressions. Statements are very simple and very easy, as we said, that anything that doesn't return a value. So as we said that in Rust, anything without semicolon at the last line in the function or whatever, like we have done here in this variable, is going to immediately evaluate to whatever that operation is. However, statements almost always end with semicolon. So if you would do, for example, let x equal to 10, you can't say, for instance, let y equal to let x equal to 10, because this doesn't return anything. So you cannot assign it to another statement. So very quickly, example for statements. Variable declarations are considered to be statements. So like we said, like we have given the example, let x equal to 5. This is a statement. Function definitions, the function definition in itself is considered to be a statement because it doesn't return anything. Also the control flow statements, so if condition, while condition, etc. All of the control flow statements. So let me give you a final example. I hope this was not too long for you guys. Final example on functions, okay? So I want to create a function that returns the BMI, the body mass index. The body mass index, or the BMI, is equal to the height in kilograms, for instance, divided by the height square. So the height in meters square, okay? So this is the formula for the body mass index. So how to do that? Okay, so first of all, we have our main function. So we're not going to touch that here, but you just add a comment here calling the BMI function that I'm going to create now. So let's do it very, very quickly. We have the function. I'm going to call it calculate underscore BMI, open close parentheses, and then I'm going to define my parameters, weight underscore kilograms. That's going to have a data type of F64, floating point with the 64 bits. Also, I'm going to have a height height underscore in meters, and that's going to be also F64. So F64, and this is going to return, this is the function that returns a value. So this is going to return F64 data type. Then I'm going to take the weight divided by the height multiplied by its own. So height multiplied by height. Now I'm inside my main function. Let me declare these variables, the parameters actually. One is i32 and the other one is f64. But as we have when we have actually set the parameters for the weight and the height. Here we have set it to F64. That's why you can see here that this is I32, which is not correct. So we need to set it like that. Now let's assign this function to a variable. This variable is BMI, and the function is calculate BMI. We have different arguments to pass. So we have actually we have our weight and we have our height. Okay, good. And then finally we're going to print that line. So print line, I'm going to say your BMI is, we're going to format it this way to display 2 decimal points. So if it has, let's say for instance, 2.345, whatever, it's going to display only 2.34, okay, 2 decimal points. And we want our BMI. Okay, now let's go ahead and run that. Perfect. Your BMI is 21.13. So that's the end of the functions lesson. Hope it was useful for you guys, not too long. Thank you so much for watching the whole thing, and I will see you in the next video. Hello and welcome back. In this part, we're going to study ownership in Rust. First, let's understand why ownership exists and the problems it has solved. As you know, there are a number of programming languages that let you control the memory like C and C++. They allow you to reserve a part of the memory, and when you finished using this part of memory, it lets you release or free this part of memory. The problem with this system that it creates bugs, because you might have freed the memory more than once, or you even forgot to free that chunk of memory. This is of course for the languages that let you totally control the memory. Now, this issue was solved by some programming languages by introducing the garbage collector. Now, the garbage collector has a role of reserving the data in the memory, and then once the programmer is done dealing with this data, the garbage collector releases this part of memory. Now, this operation is done at the runtime in the background, and this is one of the main drawbacks of garbage collection. If it wants to clean up the memory, it will stop the program. And by the way, that is the freezing which happens for a few seconds in your program. So blame it on the garbage collector, as it stops the program to clean up the memory, and when it's done cleaning, the program resumes working. So this actually has created a slow performance and inefficient outcome, not recommended for those applications that need powerful memory resources. Now let us see how Rust has solved this issue by a new concept called ownership. And by the way, last month the White House issued 16 pages on cybersecurity. And as you can see here, it says that the White House's Office of the National Cyber Director urges developers to move to memory-safe languages such as Rust as soon as possible. We have known for ages that we should use memory-safe languages like Rust, but after lifetimes of deploying everything in C and C++, it's not easy to do so. So you can see that even the White House recommends you using Rust for memory safety. Okay, this issue is 19 pages actually. Back to the building blocks, a path towards secure and measurable software. And you can see that's February 2024. And let's search for the word Rust here. So take a look at that. According to experts, both memory-safe and memory-unsafe programming languages meet these requirements. At this time, the most widely used languages that meet all three properties are C and C++, which are not memory-safe programming languages. Rust, one example of a memory-safe programming language, has the three requisite properties above, but has not yet been proven in space systems. So as you can see, the Rust programming language is going to be very popular in the future, and I can tell you that the average salary for Rust programmer in the United States is around $120,000 a year. Now in Rust, every value has a single owner, and there can only be one owner at a time. Actually, ownership rules help manage memory efficiently and prevent common bugs. And as we're talking about ownership, we will have to talk about borrowing and references. So borrowing in a nutshell allows you to temporally borrow references to values. And this actually enables safe concurrent access without sacrificing the memory safety. And I'm going to explain that in details. Now, there are very important three rules of ownership, and these rules actually are defined here in the Rust book. And the book recommends to keep these rules in mind. You don't have to know them by heart, but it's good to keep them in a corner of your mind. So the first rule is each value in Rust has an owner. Second, there can only be one owner at a time. Third, when the owner goes out of scope, the value will be dropped. So you will need to be aware of those rules, otherwise the Rust compiler is going to jump in your face, yell at you, telling you that you have violated one of those rules. Now let me give you 3 examples on the 3 rules so you will understand better. So let's take an example on the first rule, which says that each value in Rust has a variable that it's its owner. Okay, let me first create the main function, and inside the main function I want to declare a variable s1, and this s1 is going to be a string and we're saying here Rust, for example, for simplicity. Okay, so s1 is the owner of that string. The Rust value only is owned by the s1 owner. Okay, I hope this is clear. If I will create a function that will calculate the length of that string, and this function takes s, and this s is the input, right, the string, but it's not going to be the value of that string. It's going to be simply a reference to that string. So any reference is going to be preceded by this ampersand sign or the and sign. So the input in this case is not going to be a string, but a reference to the string. And it's going to result in usize or unsigned size. And we want here the s.len. Now let's go ahead and declare another variable that's going to be the length. And we're going to invoke the calculate length function. And we're going to pass, and be careful, I'm not going to pass s1. Okay? I'm not going to pass the owner. I'm going to pass a reference to that owner. Okay, so this is a reference. Okay, reference to that string. So it actually borrowed the s1 by this reference and s1. So that's the reference and that's the original owner. All right, now let's print. Let's do print ln, and we will pass s1 and the length of the s1 by passing the reference of s1. And that's exclamation mark. Okay, let's run that. Let's see if we'll do cargo run, compiling, and the length of Rust is 4. So actually Rust has accessed the string's data without taking the ownership. The ownership of the string remains with the s1. The next rule says that there can be only one owner at a time. And now I want to give the ownership of the string to another variable. I'm gonna call it s2. So I'm gonna say s2 is equal to s1. So what we have done here is that we have actually transferred the ownership of that string in s1 to a new variable called s2. Let me show you if we will do print ln and we'll do s1. Let's see what will happen. Here we have an error because s1 no longer owns the string. It now belongs to s2. So let me just do like this, and let's run for s2, and it will compile normally and it will print Rust. So this is the second rule. There only can be one owner at a time. Now let me comment all of this out again, and let's do the last rule, which says that when the owner goes out of scope, the value will be dropped. And let me give you another example. Let's do fmain, and again let's do s1 is equal to string from, and again let's do Rust. And now I want to show you if let's just bring this here, this calculate function, and let's again declare this len variable, calculate length, and we'll pass here a reference to s1 variable, and we're going to do print ln, and then here we will do s1 and len. But what I want to tell you is that the s1 outside of this scope will be dropped out of memory. Okay, so s1 goes out of scope and the value will be dropped once outside of the scope block, out of scope. And if I will create a function called print lost, and I will pass s, which is a reference to the string, And if I will try to print the reference to S1, let me show you what will happen. You will find here that cannot find value S1 in this scope. All right, if you have any questions, please let me know in the comment section below, and I will see you in the next lesson with borrowing and references. Hello and welcome back. In this part, we're going to study borrowing and references in Rust. In the last lesson, as we have seen, we have studied together ownership, and we understood that how ownership is very unique to Rust programming language and how ownership is very important for memory management. Well, in Rust, managing memory is crucial for ensuring both safety and performance. But what the word safety means here? I've seen a lot of YouTubers, programming YouTubers, they talk a lot about safety in Rust, but no one seems to explain in details what safety means, why safety is important in programming language, and what is safety to begin with. As a matter of fact, safety refers to the prevention of certain types of bugs and errors that commonly occur in other languages like C and C++. Things like null pointer dereferencing, dangling pointers, buffer overflows, and data races. And I will create separate videos to explain each one of those errors. Maybe not all of them. I will choose two, let's say pointer dereferencing or data races, or maybe dangling pointers. So let's try to understand what references is. Actually, borrowing and references are the same thing. Well, basically you create references by borrowing from the original owner of that value. Okay, so we have, as we explained before in the last lesson, we have only one owner, which is the variable that has only one value. So you cannot have multiple owners for the same value. So let's say that references in Rust enables you to borrow values without taking the ownership. And this is very important for efficient memory management. Actually, Rust doesn't allow you to have multiple owners for the same value. That's why we have to create references by borrowing from the owner. Also, it's very important to know that references can be both immutable and mutable. So, immutable references allow you borrowing without modification, and of course, mutable reference allows you borrowing with the ability to modify the data. And to create a reference, simply you will add the ampersand before the variable you're referring to. Let me give you an example so you will understand better. Let's declare a variable x equals to 5. That's going to be integer i32. Now I want to create an immutable reference to the x variable. Well, we can declare a new variable. Of course, you can do like that, okay? But that's not good for the memory. You're going to transfer the ownership of x to r totally. In that case, x will not exist anymore. So instead, we can create a reference. Simply, you will add the ampersand before the x. And of course, Rust being pedantic, add the underscore before the variable's name. All right. Okay, so let's go ahead and do cargo run. Compiling. And as you can see, value of x is equal to 5, and also value of r is equal to 5. R being the reference to x, and it has the same value as x. But it's not the owner of that value 5, but rather it's referring to that original owner of that value 5. So mutable reference simply means that you can modify in that reference. You can increment, you can decrement, you can modify in that value. Let me actually try to do it this way. First, I'm going to show you the error. So I want basically to increase the 5 by 1. The correct way or the proper way to do that is to add an asterisk underscore r. So that's the reference. And I'm going to increment it by 1. So immediately you can find that red squiggly ugly line telling you that cannot assign to asterisk underscore r, which is behind a ampersand reference. Underscore r is a reference, so the data it refers to cannot be written. It also tells you to consider changing this to be a mutable reference by adding the keyword mute. First, let's go ahead and try to run that. Again, we will have this compiling error telling you that the underscore r is a reference, so the data it refers to cannot be written. And again, the suggestion here, let underscore r equals 2. And you can see that he has added the keyword mute after the ampersand to change that underscore r to be a mutable reference. Okay, so let's go ahead and do that. Do like this, like this. So what you will need to do here is to add that keyword mute after the ampersand, but not only to the reference, we'll need to do the same thing for the original owner. So also you will add the keyword mute here. So you transferred the original owner to be a mutable owner, and also you made the reference to that owner to be mutable as well. And you can see here that the data type is i32, but the ampersand mute was added to it automatically. Okay, so let's go ahead and try to do cargo run. And indeed, the value of _x was updated from 5 to 6. Also, let's try to do this way. Let's do -3. So it will increment by 1 and it will decrement by 3. Let's take a look to what we will have. So we will have value of _x equal to 3, because from 5 to 1, that's 6. 6 minus 3 equals to 3. So what we'll have actually if we will print that value of r, if we'll do like that, for example, what will happen? Immediately you can find here that there is a squiggly line and an error, of course, telling you that cannot borrow _x as immutable because it's also borrowed as mutable. Immutable borrow occurs here. Okay, this is one very important rule. You can have only one mutable reference or many immutable references. Okay, so you can have either one mutable reference to a value or any number of immutable references. Okay, so suppose that we have a struct representing a bank account. So let's create quickly a struct that's going to be called bank account. And that struct is going to hold the owner, which is string, and also will hold the balance, which is going to be F64 data type. Now let's create a function to withdraw money from the account. I'm going to create an implementation for the bank account. And inside here, I'm going to create that function. We will call it simply withdraw. So listen carefully. In this withdraw function, I want to ensure that we cannot simultaneously have mutable access to the account to update the balance and immutable access for reading the owner's name, for example. Okay, so how to do that? Simply, I'm going to add here mutable reference to self, also amount F64 as input, as a parameter, and I'm going to print, so withdrawing whatever the amount is and whoever the owner of that account is. Okay, so we'll have here amount and self.owner. And of course, we're going to decrement the balance by the amount being withdrawn from the account. So self.balance is being decremented by the amount. Now let me create a second function to check the balance of the account. I'm going to call it check_balance. It's going to take reference to self only. So again, listen carefully. I want to ensure that while we are checking the balance, which has immutable access, no other part of our code is modifying the balance, which has a mutable access, right? So the way to implement that is we're going to simply print ln. I'm going to say account owned by has a balance of whatever. And here self.owner and self.balance. Now let's go ahead to the main function here. So I'm going to create a mutable variable, which is account. That's going to be equal to the bank account struct, and we'll have the owner Alice. Okay, and we'll change that to string, to _string. And the balance I've put it here F64, so it's going to be floating point. So let's do 150.55 for instance. So that's our account. Now let's do the immutable borrow to check the balance. So here immutable borrow to check the balance, I'm going to take the account dot check balance. Let's go ahead and run that. Account owned by Alice has a balance of 150.55. Okay. Now let's do the mutable borrow to withdraw money. So we'll withdraw 50, for example. So account dot withdraw, and we're going to withdraw 50.50. Let's do 50. Okay, let's do 45.50, whatever. Okay, Control S to save, open the integrated terminal, and again, let's run that again. And what do we have here? Withdrawing 45.5 from account owned by Alice. Okay, so everything looks to be working perfectly. We have the immutable borrow, so we're checking only the balance, but also we have mutable borrow to withdraw the money. And of course, you can check the balance again after the withdrawal. So if you will do like that, Control S, let's run that again. You will find here that the account owned by Alice has a balance of 105.05. Okay, that's deducted or withdrawn or decreased by 45.5. And why this has successfully compiled, we have said that you can have only one mutable borrow or many immutable borrows, but you cannot have both at the same time. The reason why the code compiled successfully because each borrow, the check balance and withdraw here in both functions, each is in its own scope, so they do not overlap, and therefore there is no simultaneous mutable and immutable borrowing of account. So that's it for borrowing and references. Thank you so much for watching, and I will see you in the next lesson. Hello and welcome back. In this part, we're going to study variables and mutability in Rust. Now, in Rust, variables are immutable by default. This is something you need to know. Immutable means that you cannot change it. So immutability means the inability to change a certain variable. Once it's initialized or once it's declared, you cannot change its value by default. And be careful, I'm talking only about variables. I haven't talked about constants yet, and this is going to be the next lesson. So when a variable is immutable, its value cannot be changed after it's assigned. And if you'll try to do so, you will have a compilation error. And that's exactly what the Rust book tells us. It says here that when a variable is immutable, once a value is bound to a name, you cannot change that value. To illustrate this, generate a new project called variables, blah, blah, blah. So I'm going to show you that. I've already initialized a project or created a project. It's called _06 variables, and we're going to see that now. So let's say that I want to declare a variable. And as you know, in Rust, there is type annotation. So you can do this as for example, U8 or U16, unsigned data type for 16 bits. And that's going to be equal to 5, for instance. In variables, it's not obligatory to do that. If you will leave it like this, it will be fine. It can compile and you will not have any errors. But it tells you here that if this is intentional, prefix it with an _a. We can do that just to calm him down. All right? But even if you will not do this, it will compile fine. Now let's print the value, so println. Now we'll do the value of a is okay, and a here. So that's the first thing. Now, if you will try to change the value of this variable a to, let's say, 10, you will have a big problem with the Rust compiler. So let me now show you. If we'll do cargo run, and we have a big nasty error here. So it says here cannot assign twice to immutable variable a. So that proves what I said and what the Rust book said, that every variable by default in Rust is immutable. You cannot change it. Again, I'm talking about variables and not constants. Then after here, it says let a equal to 5. First assignment to a, consider making this binding mutable. So it tells you, or it suggests what you have to do in those backticks, mute A. So let's go ahead and do that. Let me just exit. And if you will add the word mute, immediately you will find that this ugly squiggly red line has disappeared, and you will find that we don't have any issues or any problems. So let's try that again. And as you can see, it compiled, no problem. The value of A is now 10. So this is it, folks. In order to change an immutable variable in Rust, you have to add the keyword mute, M-U-T, to change it from an immutable to a mutable variable, and then you can assign to it a different value if you want. All right, so that was it in this part. In the next part, we're going to study constants, and we'll see how it's different from variables. Hello and welcome back. In this part, we're going to study constants in Rust. In the last lesson, we have studied variables and mutability. So let me go ahead and create a project real quick in my folder _07 constants. So you know that to create a project in Rust, you can do cargo, new, and the name of the project. But as I have a folder already, I want to initialize a project directly inside that folder. So what I can do in this case, I can say cargo space init, and it's going to initialize a project directly inside my folder. All right, let's go to main.rs. Let's close the integrated terminal. And let's just add a quick title here. All right, you guys, so constants, like immutable variables that we have discussed in the last part, constants actually are values that are bound to a name and are not allowed to change, exactly like variables. But in fact, there are few differences between constants and variables. That's why I was very careful the last time. I told you, do not confuse the variables with the constants. Granted, both are immutable, but the first difference between a constant and a variable, that in a constant, you're not allowed to use the keyword mute with constant. So if you will do let mute x equal to 5, for instance, okay, you cannot say, so first of all, you declare a constant by using the keyword const, C-O-N-S-T, and it suggests here that y, it should be capital, and also the type annotation should exist, and then the assignment for the variable. If I will do y like that, and if I will just say 10 like this, this is not according to Rust rules, but I'm going to tell you that in a second. So you cannot come here and do like this, const mute equal to, or const mute y equal to 10. If I'm going to print the value of x, for instance, and if I'm going to print the value of y, okay, if we're going to do that, and let me do cargo run, we're going to have an error, of course. Why? Because missing type for const item. So actually hasn't, okay, so that's the first error. That's what I was looking for. So cannot be mutable. A constant is by default immutable. Not only that, but also you're unable to change it to immutable. Okay, so it's by default immutable. It will always stay immutable. You can never change a constant to mutable. So that was the main error. So missing type for const item. So yeah, I told you the second one is you need to provide a type for the constant I32, for instance. All right, so the basic difference is that you cannot use this keyword here, this mute in front a constant. You cannot do that. All right. The second thing in constants, if you will declare a constant, it should be with capital letter like that. So this is by Rust rules. Also, when you declare a constant using the const keyword, of course, you are obliged to enter or to add the type annotation. So let's say I32, for instance. So based on Rust rules, this expression is correct. Okay, const y with type integer for 32 bits equal to 10. Now let's try to run that again. All right, it has printed here the value of x is 5, the value of y, and notice that the y is underlined. Now it's complaining here why. Let mute x equal to 5, remove this mute. Yeah, because we're not using it. We're not changing anything on x, so it will not make a difference. So that's why it doesn't like it, but we will leave it. Also, a distinctive feature of const is that you can declare a const in any scope, including the global scope. Global scope means outside of the main function. So you can come here and say you can declare a constant here. Okay, with the type annotation. Yeah, this is a good suggestion. So if we'll say const pi equal to 3.14, and that's of data type floating point 64, keep it like that. And if we'll go here and do like this, the value of pi, all right, and let's try to run that. You can see here that the value of pi is 3.14. Okay, it has printed that with no problems. Let's also try to create another one, const, the one that's actually here in the book, this one. Let's copy this one. Let's get back here and let's paste that in. Const 3 hours in seconds with type annotation unsigned 32, 60 multiplied by 60 multiplied by 3, that means 3 hours in seconds. Okay, so if I want to print ln, the value of not e, but 3 hours, I don't know why I did like this, 3 hours in seconds is, and we'll pass that, 3 hours in seconds. Okay, cool. Let's run that and we'll have an error. Okay, okay, 3 hours in seconds. That's odd. You shouldn't trust AI always. Okay, let's run that one more time. And indeed, we have the value of 3 hours in seconds is 10,800 seconds. And that's it. Those are the rules for constants in Rust. In the next video, we are going to discuss shadowing and explain what shadowing is in Rust. Hello and welcome back. In this part, we're going to explain shadowing in Rust. First, let me get outside of the constants. Let's go to the 8 shadowing. And let me do cargo init. All right. First of all, let's explain what shadowing is. So the last two concepts are very clear, constants and variables. Now shadowing is not very clear, right? Even the word is not clear. What shadows what exactly and what the shadow has to do in programming. Okay, so as the Rust book tells us here, you can declare a new variable with the same name as a previous variable. So again, there was the guessing name tutorial. This was in chapter 2. I didn't cover that because, you know, there was a lot of stuff that was not covered yet. So I think guessing game should come after we explain the basics. I don't know why they did it this way in the book. But anywho, they say here that you can declare a new variable with the same name as a previous variable. And Rusticians say that the first variable is shadowed by the second. I'm going to explain that by an example, which means that the second variable is what the compiler will see when you use the name of the variable. Okay, what's all that means? Let's take actually this example right here. All right, simply what this means, if you have a variable here that it's x, okay, x equal to number 5. Now, if you will create or if you will declare a new variable with the same name x, and you're going to take x, which was previously declared with the value of 5, and add to it 1. Then naturally, this x will equal to 6, right? This is exactly what shadowing is all about. Basically, what you have done is that this second variable x, which actually is this x, right? So both of them are old, if you want to say, and that's the new x. So that's the first and that's the second. The first was shadowed by the second. So the first x was shadowed by the second x, or the first variable with the same name was shadowed by the second variable with the same name. And when you will print x, the compiler in Rust is going to read only this number 2. You can do shadowing again. You can do let x equal to x plus 1. And this is going to be 7, exactly, because we have first here, we have 6. If you will do the same line again, it's going to be 7. If you want to increase this to not 1 but 2, for example, it's going to be 8, and so on. And you're going to continue to shadow and shadow and shadow. So shadowing simply means that you create a variable with the same name and you are shadowing the first one. So that's it simply. The second variable is what the compiler will see when you use the name of the variable, and in our case it's x. So the second variable here overshadows the first and takes any uses of the variable name to itself. You are shadowing the first by creating a second, and you're taking the first and incrementing it by 1, multiplying by 2, or doing whatever. So that's here outside. If we have a different code block inside our main function, we have let x equal to x multiplied by 2, okay? In that case, the actual result of this is going to be 6. This 6 is going to be replaced by that x here, right? And multiplied by 2 and stored in that new variable, which has completely shadowed the first one, right? So we have x, 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 and the 3 are different basically. The first one is 5, the second one is 6, and the third one is 12. So let me just add here a comment. This result is, of course, 5, 6, and here result is 12, exactly. So that's the concept of shadowing in Rust. So let's go ahead and run that. First, let me just delete this. Okay. Let's do cargo run. Compiling, and you can see that the value of x in the inner scope is 12. That's exactly what we have said. Oops. Here, this is 12. Okay. And the value of x is 6. Okay. So the value of x in main function. Okay, one more very important point, that shadowing is different from marking a variable as mute. Okay, so shadowing is not the same as marking a variable as mute or mutable, yeah, mutable. Okay, how so? Simply, if you accidentally try to reassign to this variable without using the let keyword, you will have a compile time error. If you will simply do like that, x equal to 10, if you will try to run that, you will have a compile error or compile time error. It tells you here that cannot assign twice to immutable variable. Okay, so first assignment to x, that was here where the result is 6. And the other difference between mute and shadowing is that because we are creating a new variable when you use the let keyword again, so you used it here, then you used it here, then we can use it again. We can say let x equal to x multiplied by 1,000. Okay, and if we'll do like that, or even we can keep it like that, take a look, you will have here 6,000, right? That's in the main function. So you're allowed to use the let keyword as many times as you want if you want to do shadowing. You have actually changed the type of the value, but reused the same name, the same x name here, but changed the value inside. Okay, there was a very cool example here, that about the spaces. So it tells you here that say our program asks a user to show how many spaces they want between some text by inputting space characters, and then we want to store that input as a number. So let space is equal to a number of spaces we don't know, and then we're getting the length of the spaces. So the first spaces variable is a string type, but the second spaces variable is a number type. So shadowing spares us from having to come up with different names such as space stir, space name. It's going to be spaces, but you're actually changing what you want to be in that spaces variable. And that's the beauty, or that's the power of shadowing, I may say. So instead, we can reuse the simpler spaces name, exactly. However, if you try to use mute for this, we will get a compile time error. So if you'll try to put mute in front of spaces, and let's just see the error, you can see here that mismatched types, first of all, and then after for those spaces between double quotes, an expected answer, that's a slice string, found unsigned size. So this was shadowing, guys. If you have any questions, if it's still unclear for you, this part is theoretical. Still, it's very, very important. I know sometimes it's boring, but it's very important. You need to know those basics, because without the basics, you will not be able to code yourself. Okay? So that's a little tip for you. So that's it for this lesson, guys. Thank you so much for watching, and I will see you in the next part. Hello and welcome back. I honestly am surprised that you clicked on this video. Comments. As people tend to disregard comments in programming. Comments are a very important part of coding, especially if you work with 2 or 3 team members. It's important for all of you to understand what everybody else is doing. It's important to describe the mysterious parts or the difficult parts for someone else to read your code. He needs or she needs to understand exactly what that code block is doing, and you can achieve that through commenting. Now, the compiler in Rust, or the interpreter for that matter in Python, for example, tends to ignore the comments, so it will not execute the code line where the comments are being placed. So simply in Rust, commenting is done by // for one line comment. This is a one line comment. Traditionally, if you want to put a comment in front of line or attribute it to one line, you can put it above that line. So this is for printing hello world. Also, you can put it here next to that line. So again, you can do // This is a comment for printing I feel lucky. All right, so that's the general idea. If you have a line, for example, if you want to comment that line, for instance, you can simply put // to comment that line out. If you work with Visual Studio Code, you can hit Ctrl// and it will comment it automatically. Let's say, for instance, that we want to comment these lines. It's not very efficient really to do like this, to put // in front of each line. The best way to do block commenting is by doing /* like that. Okay, and you can just enter this, and you can put this here, and now you have this block comment like so. So this is how you do block commenting in Rust. And as you can see in the book, these are the non-doc comments. Comments follow the general C++ style of line / and block /, and /comment forms. Nested block comments are supported. That's everything that I have for you today for comments. And with that, thank you so much for watching, and I will see you in the next lesson. Hello and welcome back, guys. In this part, we're going to study the control flow in Rust. More specifically, the conditions or the if expressions. In any programming language, controlling the flow of execution is based on 2 things: conditions and repeating actions. Now I know most of you didn't know that conditions and repeating actions are related to each other, and together they are called control flow. So in this tutorial specifically, we are going to talk about if expressions. Before that, let me just initialize a new project. Okay, let me just shut that. Let's go here to I'll close this and we'll go to the source in the main and let me shut that. All right, so let's talk about if, else, or the if expressions. Now I will assume that you know already what if expressions are, but still I will say this for those of you who have no idea what the flip I'm talking about. So it says here simply, an if expression allows you to branch your code depending on conditions. So basically you provide a condition and then state, if this condition is met, run this block of code. If the condition is not met, do not run this block of code. Simply put, if it rains, take with you the umbrella, else do not take your umbrella. That's all what if expressions is all about, for those of you who do not know. So let's suppose that we want to create a small program to check whether a certain person with an age less than 18 to let them know if they are eligible to drive a vehicle or not. And you want this program to behave differently based on whether this condition is true or false. So to do that, I'm going to define age. So let age equal to, let's say 18, and you can do type annotation here. So we'll say an assigned value of 16. All right. After, I want to put a condition. This condition is going to check if the age is equal to or more than 18. In this case, you can drive a car, else you're still a minor, or you still cannot drive a car. To do that, I'm going simply to say if age is more than or equal to 18, in this case, between curly braces, notice, println you're old enough to vote. That's funny. This is by tab 9, by the way. It's like GitHub Copilot. So we'll say here, println, I'm just going to change the message. You can drive a car. After the curly brace here, I can do else. In this case, and that's again tab 9, println you can't drive a car. All right, so that's the condition. If we will run our program, we'll do cargo run. You can see here that you can drive a car because the condition was met and the age is equal to 18, and our condition was if age is more than or equal to 18, then we want to print you can drive a car. By the way, if you want to bypass those ugly warnings, you can come in your project here and you can just type that #, exclamation mark. Those square brackets allow warnings in parentheses. Let's try that again. Let's do cargo run. And you can see it's much cleaner. And we have, of course, the same result. But this is in case of only one if expression. But sometimes we have multiple conditions with else if. And for those of you who are programming in Python, it's something like elif, because basically elif, it's else if in Python. Also, it's in JavaScript. In most of the programming languages, it's else if. So it's the same in Rust. Let's have another example. Let me just comment all of those lines out. And I will come here, we'll say let number, for instance, so we'll have a number, and that number is equal to 6. Okay, let me just add a comment here, multiple conditions with else if. So number is equal to 6, and I want to check out if number with the modulo sign 4 is equal to 0. In other words, if this number is divisible by 0 and will not return any remainder. So in that case, I want to print a line says that number is divisible by 4. Now we want to check out different conditions, not only one, because if only one extra condition, we will just type else. But if we have different conditions to check, then in this case, we'll do else if number is with the modulo 3 equal to 0. In this case, we want to print out that number is divisible by 3. The same case with the number modulo 2, we will print number is divisible by 2, else we will print number is not divisible by 4, 3, or 2. All right, so these are the different conditions that we are checking in case of the number is equal to 6. Of course, if we'll change the number, the condition checking and the results are going to be different. Okay, so let's go ahead and run that. Okay, so we have here number is divisible by 3. Of course, because we have defined here, we have hard-coded the number to be 6. You can be more creative. You can, have this small program that you prompt the user to enter a number. And then based on that number entered by the user, the checking is going to happen. And of course, the result is going to be different according to the number entered. The last example that we have is we can use if in a let statement. How so? Let's say, for instance, that we have a certain condition which is set to true, for instance. Okay. Now we can do like that. We can define or declare a variable called number. This number is going to check if condition is true, then we want 5. Else we want 6. So if the condition is true, number or the value of 5 is going to be assigned to that variable number. Else 6 is going to be assigned to number. And of course, you can print that number. Instead of doing that, we can do like this directly. All right. So in this code, number will be assigned either 5 or 6 based on the value of the condition. Let's check out the result. Number is indeed 5. Why? Because the condition is true. Now, if you will change that to false, we'll run that again. Of course, number will be 6. Now remember that it's very important to ensure that the types of values in each arm of the if expressions are compatible. By the way, this is called arm, okay? Or else you will encounter errors when you will compile your code, okay? So for instance, that if we will change this 6 here to 6 like this, okay? That's not correct, because the expression in the if block evaluates to an integer, and the expression in the else block evaluates to a string. And if we'll run that, of course, we will have a type error. So you can see here that if and else have incompatible types. That's a type error. So basically, if and else have incompatible types, if expected integer and else found a string. And that's basically everything you need to know in the conditions, which is a part of the control flow in Rust programming language. Thank you, and I will see you in the next part. Hello and welcome back. In this part, we're going to study loops in Rust programming language. So in programming, there are often situations where we need to repeat a block of code multiple times. So actually, Rust provides 3 types of loops: the loop, the while, and the for loop. So the loop keyword tells Rust to execute a block of code repeatedly until you explicitly tells it to stop. So it's unconditional loop. It will continue running until you tells it to stop. Let's take an example. Let's, for instance, do loop. So you simply will type the word loop. You will open close curly braces, and let's print, for instance, hello world without the break. And let me just minimize this a bit. Let's do like that. Maximize the terminal and do cargo run. Of course, it will continue running hello world to the infinity, unless of course you will stop it by hitting Ctrl+C. So you saw that when we have ran this program, it continually printed hello world until we manually stopped it. So that's not very good. Let's get back. Let me just comment those lines out. Now let's check out if we want to return values from loop. The book tells us here that one of the uses of a loop is to retry an operation that you know might fail, such as checking whether a thread has completed its job. You might also need to pass the result of the operation out of the loop to the rest of your code. And to do this, you can add the value you want returned after the break expression. So the break expression you can use to stop your loop. That's why tab 9 has automatically put the break after we have tried that last example, when we have printed hello world. So that value will be returned out of the loop, so you can use it as shown here. So you can see in this code a mutable variable counter, which is set to 0 initially. Then we have a result variable assigned to it a loop. This loop has inside it a counter that's incremented by 1. Then inside that loop we have a condition. So here we are using the if expression that we have learned the last lesson. That's why the conditions and the loops together are called control flow. This condition says that if counter is equal to 10, we want to break, and then we want to return counter multiplied by 2. So the counter is going to start from 0 and it's going to increment by 1 until it hits number 10. Then it will take the number 10, it will multiply it by 2, and then it will print it here down in the console. And of course, the result is going to be 20. Also, to show you that, I have copied the code. Let's go ahead and run it. Let's do cargo run. And of course, the result is 20. You can do any sort of operations. You can do till 20, and instead of multiplication, we can do minus. Let's do 100 for instance. And we can say here the new result is, let's run that again. You can see here the new result is minus 80. All right, it did the calculation, it has printed the result. Also, we can create loop labels. I'm going to show you loop labels. So when you deal with loops nested within one another, that's where you use the loop labels. So nested loops, for those of you who do not know what the flip I'm talking about, it's like layers of cake. So you have a loop, inside it there is another loop, and inside the other loop another loop, and so on. So it's like, you know, the Russian nested doll. Basically, the break and continue statements are going to apply to the innermost loop by default. If we'll get back to our book, you can find this example. This is the main function inside it. So again, we have a main function inside it, mutable variable. So again, this is the main function. Inside it, we have a mutable count. It's set to 0 initially. Then we have this single quotation counting underscore up and colon. This loop label has a name which is counting underscore up. So why we actually have assigned a label? Again, as I said, when you deal with nested loops, the typical behavior or the default behavior is that the break and continue statements are going to apply to the innermost loop by default. We have an outer loop and inner loop. That's the first one, and that's the second one. So this is the outer, and this is the inner, okay? So this label here, so what will happen is that we're going to print count is equal to whatever the count is. Then you're going to print that count. Again, we have a new variable called remaining, which is a mutable variable, which is set to 10. Okay, so this is in the body of the outer loop. For the inner loop, you have println remaining equals to remaining. So initially is set to 10. And we're going to check out if the remaining is equal to 9, we're going to break outside of the loop. But notice this condition, if it's met, this part is going to be, will not exist anymore because we'll break outside of the loop. But the count is going to continue. So the count is going to continue until it hits 2. When it hits 2, it's going to break off the counting up, which is the label. Let's go ahead and run that. exactly as expected. So count is 0, remaining is 10, remaining is 9, and count is 1. Again, printing, remaining is 10, remaining is 9, and count is 2, then remaining is 10. So I have a question for you. What if we'll put the remaining minus equal to 1 outside of that inner loop? We'll put it here with the outer loop. Of course, that remaining printing is going to, print forever. Why? Because there is no decrementing, there is no action on that remaining. So that condition, if remaining is equal to 9, will not be met in the first place. It will come on that line and will print it forever. Of course, after it will print the count. So let's go ahead and try that. I made quickly Control C just to show you. And we'll do here the last loop. So the while loop runs the loop as long as a condition holds true. So you can say simply while number is equal to 10, for example, do this. So conditional loops with while. A program will often need to evaluate a condition within a loop. So while a condition is true, the loop runs. When the condition ceases to be true, the program calls break, stopping the loop. It's possible to implement behavior like this using a combination of loop, if else, and break. You could try that now in a program, blah, blah, blah. So that's their example. We're going just to write it real quick here. So let's have mutable number. So that number is equal to 3. And we can say here, while number is not equal to 0, for instance. In that case, I want to print ln the number. And here we will decrement the number by 1. So number minus equal to 1. So what will that do simply is that it's going to evaluate the number to 3. So that's fine. And we'll say here that while the number is not equal to 0, which is true, we're going to print ln the number. While that is happening, we're going to decrement in each iteration that number 3 by 1. And then after we can say here break, for instance, or you can do anything else. You can, for instance, do print ln hey. All right, so if we'll do like this, let's do cargo run. It's going to print 3, 2, 1, hey. If you will do break, it just printed 3 in the first iteration, and then it broke outside of the loop, and it has printed hey. We can also loop through a collection with for loop. So what I mean by that is if you have an array, let's say this is an integer array from 1 to 6. And let's say, for instance, that for element in A, we want to print the element. All right. So for each iteration in that array, we're going to print the element. So it's going to print 1, then 2, then 3, then 4, then 5, then 6. Let's go ahead and try that. So you can see here that it has printed everything. 1, 2, 3, 4, 5, 6. You can do the same thing for any type of array. So let's say, for instance, let me actually do let b is equal to, and let's have here any strings. So those are strings, for example. So A, B, C, D, E, F. And so we can repeat that actually. Instead of A, we'll have B. Instead of element, we'll say letter. You can see here from 1 to 6, and then from A to F. All right, guys, so that's it for this lesson. Thank you so much for watching, and I will see you in the next lesson. Hello and welcome back. In this part, we're going to study structs in Rust programming language. As the Rust book tells us that structs are similar to tuples, in that both hold multiple related values. And like tuples, the pieces of a struct can be different types. So struct can hold integers, can hold booleans, can hold strings. So let's take a look how a struct will look like. So as we saw in the documentation, structs are used to name and package together related values similar to tuples. So a tuple, for example, will look something like this. Let's have a rectangle, for instance, rectangle. This rectangle is equal to 200 and 400 or 500, doesn't matter. Okay, so this is the rectangle tuple. It has width and height. Okay, and immediately you saw that it has type inference, which means that it already identified that this is I32 for both numbers, basically. However, unlike tuples, each field in a struct is named. This provides clear identification of what each value represents. So this feature makes struct unique, more flexible and expressive compared to something like tuples. Data is basically accessed solely if you will order it. I know that I'm talking gibberish. To make things clear, let me just have a comment here and say this is a struct. So let's have a struct of a book, for instance. So we'll start that by typing the keyword struct. Okay, and the name of that struct, in our case, that's a book. You will open and close curly braces, and inside here you will have different variants. So the first variance here is title. The title, it has data type of string. So this is a string data type that is assigned to that title. We can create more of those. So we can have a title, we can have an author, we can have a number of pages, for instance, that's going to be I32 or U32 rather, because it's positive. Also, we can have a Boolean value, which is available or not available. And let's delete those. Let me just change. So for the title, that's fine. Author is a string, also fine. For pages, we'll have U32, and for available, we'll have bool. All right. So these are the different variants that you can create inside your struct. We can create another one. So I'm going to use the keyword struct here, and I want the name, which is going to be user. In this case, inside user, I want different variants. Each variant will have its own data type. So for instance, we have active. Active in this case is bool. Also, we will have the username. In this case, it's going to be a string, of course. Also, we can have an email. It's going to be a string. And finally, we can have something like sign in count. So sign in count, and that's going to be U64 and assigned 64 bits. All right, so that's another struct. So we have two structs now, book struct and user struct. This user struct here includes fields for whether the account is active, the username, email, and assign an account. And the beauty of the struct is that you can create an instance of that struct. Okay, it's like in Python when you create a class, you can instantiate an object by, you can instantiate that class by creating an object. So for instance, if we have struct animal, for example, you can instantiate that struct by creating a dog object. So we can create an instance by specifying the values for each of the fields. Okay, so we have active, username, email, and sign in account. Let me actually instantiate that user struct. I'm going to do user1. User1 is equal to user. And inside here, I want to set the different variants. So the first one, active, is going to be set to true. All right. So you see the idea. I think you get the idea now. Username is a string, and that's going to be whatever the name. So some username. Also, we need the email. The email also is a string, and we can say some username at m.whatever.com. And finally, the sign in account is going to be an integer or a number. So sign in account is 1. So if you will hover over here on user1, you will find that user1 is of type struct, which is user. It's worth noting here that the entire struct instance must be mutable in order to modify any of the fields inside. So we're going to turn that into a mutable struct. So if I want to update, for instance, the email, let's say, okay, if I will say, for instance, user1.email is equal to string from, and we'll say here, I don't know, another email at m.com. So let's try to print that to check out. I will say print ln, and I'll say here user email is, and then here I will just say user1.email. All right, let's open the integrated terminal and let's do cargo run. Okay, so user email is another email at m.com. So it has effectively updated the email inside our object, inside our instance of that user struct. Let me try to comment this line out, and let's do also user email. Let's keep it like that, and let's try to run that. All right, so user email is some username at m.com. That's before the updating. That's the original one inside our user1 instance here. And you can do that for the phone number, if you have phone number, for sign-in count, for everything. All the fields, you can update them. So let's continue. We can also return a struct from a function. How we can do that? Let's create a function. Let's say build underscore user, and it has a parameter of email, and that's going to be a string. Also, it has a username. Also, it is a string. Inside here, we will have a struct of user, and that user has different variants or different fields. So it has active, which is set to true. It has an email, which is initially set to nothing. Username, also nothing. And sign-in count is set to 1. I forgot one very important thing here, that we need to return a user struct. Now this example here uses field init shorthand, which simplifies the code when variable names match the struct field names. All right, so the point here is that from a function, you can actually return a user, and do not forget this, right? This means that you return a user struct from this builder user function. Also, you can create instances from other instances, right? So how so? Let's say that we have user2, for example, and user2 is, of course, is equal to the user struct, and we want a specific variant or specific field, which is the email. Of course, the email is a string from another at m.com. So here what you have done basically is that you have created a new instance, which is user2, and then use the email of user1, except of course for the fields that explicitly set to new values. So if you want to keep all of the other values the same, you would do like this. You would do user1. All right, but just I want to note here that why we have specifically chosen the email, because we have two. We have one here and we have another one here. We have updated it. So that simply means here that all other fields are the same: active, username, and sign-in count, except for the email that we have just fetched it from user1, but we have specifically stated that we want another at m.com. All right, so you can create instances from other instances. And that, in my opinion, is a very powerful feature. Also, there is something called the tuple structs. They are like normal structs, but the main difference is that they do not have any name fields. So you can create a tuple struct by saying struct, like you would do, as always, the name of your struct, and then you'll open parentheses like that, and you can say that here I want i32, and i32. Okay, we can also change that. So we have two different structs here, and also we can create some instances. So let's do let black is equal to color, and the black of course is 0, 0, 0, and we'll have a white. So let's say let white is equal to color, and here we'll change that to 255. Also, there is something called unit-like struct. Unit-like struct, like that. Unit-like structs are very specific. They have no fields and are used when you need a type to implement a trait, but don't need to store data. So you can say, for instance, struct always equal, and then you instantiate subject by saying always equal. Okay, and immediately it identifies it that this is a struct. And of course, it doesn't have any implementations. It's just a struct. It's just a class. We don't have any functions attributed to that class yet. All right, and that's everything that I have for you guys in terms of structs in Rust programming language. We have covered all of the structs that you can find in the official documentation of Rust programming language. And with that, thank you so much for watching, and I will see you in the next lesson. Hello and welcome back. In this part, we're going to study enums in Rust programming language. So first of all, what is enum? So before we get to what is enum, I would like to show you what we have studied so far. We have studied the primitive data types, the compound data types, functions, ownership, borrowing and references, variables, constants, shadowing, comments, if expression with the break and continue statements, loop, while loop, for loop as part of the control flow, structs, and today we are going to see what is enum. Enum is a versatile tool that is used to represent a type that can take on one of several possible variants. They offer basically a structured way to handle different kinds of data under a unified type, which can be particularly useful for managing related values with distinct characteristics. And you might be thinking that this looks like structs that we have studied the last lesson. In fact, we can compare this to structs, which are used to bundle related data fields, or if you remember, we said they're used to name and group related data fields. But an enum does more than that. It extends this by allowing each variant to hold different types and amounts of data. So to define an enum, you will type the keyword enum and the name of your enum, in our case IP address kind or IP address kind. You know that IP addresses are divided into IPv4 and IPv6. Using enums in this case, by the way, is very appropriate. Why? Because an IP address can only be one version at a time, despite both being IP addresses, either v4 or v6. So this situation illustrates how enums in Rust allow a value to be one of several predefined variants. So back to our Visual Studio Code, let me go ahead inside the main function, and I'm going to define an enum. So I'm going to say enum and IP address kind, open close curly braces, and we have v4 and v6. So this IP address kind enum defines that the IP address could be v4 or v6. All right, so let me go ahead now and create an instance of each variant of this IP address kind. We can do this as follows. You can simply declare that by the keyword let, as we have learned together, and I'm going to give it a name 4, and that's going to be of the IP address enum or IP address kind enum with the annotation to access that v4 variant. The same thing I'm going to do with the v6, and I'm going to change the name here. And notice here, by the way, that the v4 and v6 variants are namespaced under the enum type with those colons. Okay, this basically helps keep the code organized and clear. So we can use enums also in functions. So you can use these enums as parameters in any function actually. Simply you can create a function like that, for instance, called route. And inside route, I can instantiate from the enum IP kind. And this is with the IP address kind here, and open close curly braces. So this is a function, right? And if you will hover over the IP kind, if this is intentional prefix, so it's complaining because we need, as a Rust way, it likes those underscores. And the route function, it's never used. We haven't called it yet. So we can call it here below. So we can call on that route function. We can invoke that. We can pass the IP address kind. And we can verify that this is v4 Internet Protocol address kind. Similarly, we can do the same thing with the v6. So that's it. We have actually used this IP address kind enum as a parameter inside the function. And this allowed us to write these functions that can accept those kinds of Internet Protocol. Just going to change this because this is visually is making me very nervous. So I suggest that for should be like that, and with the underscore, okay, just to calm him down, because I can't stand those squiggly lines. So what we have here is a simple function, and we have used this function, we have called it, and we have passed the IP address kind, and we have defined that to be v4 and v6. But actually we can do more than that. So think more about this IP address type. And at the moment, we didn't have a way to store the actual IP address data. You might want to think of using structs to tackle the problem. We have learned everything about structs the last lesson. So we can, if we will use structs, for example, so using structs to solve that problem, that enum here, so let me just bring that. Okay, just to be closer to our eyes, because I'm giving the example on struct now. So let me create a struct that's going to be called IP address or adder. And we have a variant called kind, and that's going to be the IP address kind. So we have actually given a type to that kind variant, which is an enum. So we have passed actually the enum, which is the IP address kind, as a type for the kind variant inside our IP address struct. Okay, so hope this is clear. We can also have address. So this address will have a data type of string. Now I can have two different instances from that struct. So let home, for instance, home equal to the IP address. And here the kind, I'm going to define it. And kind is taking the IP address kind as type, and that's going to access the v4 variant inside the IP address kind enum. Hope that's not too confusing. So also I want the address as the second variant, and that's going to be of string data type, and that's going to be from, and we're going to say here the string slice is going to be basically the IP address, which is 127.0.0.1. That's the local host. All right. So that's the first instance. I want to create a second instance actually. So let's do like that. Let me change home to loop back. So loop back is also another instance that has v6 IP address, and the address here is, we're going to do like this, :1. So that's one way to use struct to solve that problem for storing data. So we have stored that local address data and also the type of the IP address, v4, v6, right? But actually Rust allows you to store data directly in each enum variant. You don't have to use structs. I wanted to show you that there are other ways to tackle problems. Okay, so the way to do that is that inside the enum itself, we can actually define that data type of v4 and v6. So inside parentheses, you can say here that that's going to be a string. And also this is going to be a string. And if you will hover over one of those variants, you will find here, for instance, that v4 defines an enum variant constructor, which should be called. Okay, that's informative. We know that already, and we're going to call that. So, instead of doing all of those steps, we can simply do that by declaring a variable, home. We'll have a small problem because I will need a different name for the enum. So maybe I can keep that. Let me just copy it one time. And, oops, let me take all this and put it here back above inside the main function. And down here below, I'm going to change the name of this enum. We're going to call it the same name as we have called our struct. So let's call it IP header, right? And also let me just delete that because it's complaining because we have defined the data type. All right, so back to our example using the enums to store data. So we're going to do IP address, and that's going to access the v4. And inside we can say that's going to be a string from the data that we want to store. So we want 127.0.0.1. All right. And also I need another one for the v6. And the v6 here, that's going to be our variable, which is loop back. This is going to be v6, and that's a string from :1. Okay, so by using enums, each variant here of the IP address can hold a string, and this string represents the IP address. Okay, this is more concise and, it's very clean instead of doing all that in constructs. The last example for enums that I want to show you is enhanced enums. So for the v4, I'm going to change that data type from string to u8 4 times. So u8 4 times. And also for the v6, well, we can leave the v6 to be a string. All right, and I'm going also to do like this. I'm going to write here a comment saying enhanced enums, and I'm going basically to take the same, uncomment them, and just move them here down. And we can delete this, we can delete the extra parentheses and the double quotation, and I'm going to convert those dots to commas because we have 4u8, right? So that's 127.0.0.1. It's error because I need to save that. Okay, good. And for the loop back, it's going to be a string. So I'm going to leave that as it is. And we don't have any errors. So you have seen what we have done. The v4 holds 4 u8 values representing those 4 numeric components of the IPv4 address. Okay, it holds a string and we didn't have any problem with it. Okay, so that's everything I have in enums for you guys. Thank you so much for watching, and I will see you in the next lesson. Hello and welcome back. In this part, we're going to study error handling techniques in Rust programming language. And as it tells you here in the Rust book, errors are a fact of life in software. So Rust has a number of features for handling situations in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile. And the first technique that I want to show you is called option. Understanding option T is a very important tool that you can use in order to handle errors efficiently. Option T basically is an enum. We have studied enum in the last lesson, and this enum is used when a value might not be present. So it's going to avoid the pitfalls of null references, which is common in other programming languages. And the way to define an option is by typing the keyword enum before that, then not the whole word is capitalized, so option, like that, and you will open close curly braces, and we will have two variants. We will have some that takes T and none, and let me explain that. So the option is going to check something, and if this something is positive, it's going to return some with that type. And if that something that we are checking is not present, none will be returned. I can say here that this is defining the generic option, or option rather with O capital, option type. The sum represents a value and the none represents the absence of a value. So it represents no value basically. Now the second approach is called result, also is an enum. So this result type is used for operations that can succeed with the OK T here. So if this is successful, it's going to return you OK with the type, or in case of failure, it's going to return an error. So this is particularly very useful for more critical errors where you need to specify why an operation failed and help you even to prevent it at the compile time. Okay, so now you've been introduced to the two approaches. Let me give you just a quick example on both. And what I want to do is I want to create a function. This function is going to divide a numerator by a denominator. The numerator is going to be of data type F64, or you can do it U32 or I32 as you want. And the denominator naturally is going to be of the same data type. And also it's going to return option with the data type that's exactly the same as the numerator and denominator, which is F64. And here we are going to check if the denominator is equal to 0. In that case, we are returning none. And if it's not 0, we are going to return sum with the result. Let me actually move the main function here down below. And then inside the main function, I will, maybe I can do the same thing for the approach as well. So just 1 second, guys. I will just move that above here. Okay. All right. And we don't need that. So what I want to do here is I want the result. So the result here is going to invoke that divide function. And we're going to, maybe we can do 10 divided by 0 first, to see that if we're going to use the divide function, we will see if we'll divide the 10 by 0, what we will get. All right, now I want to do match result. Then I will say sum with x. That's going to print ln and the result and the x value. And in case of none, we are going to print error, or maybe cannot divide by 0, something like that. Okay, so let's go ahead and compile our code and see what we will get. But first there is something not right. Mismatch types. I think that's the formal definition. I forgot to just comment this out. Okay, so let's go ahead and do cargo run and let's see what we will get. So compiling, and you can see here that cannot divide by 0. And in case that we will change the denominator to 2, for example, let's run that again. And you can see here that the result is equal to 5. So this is a very effective way to handle errors using option with the type. Now, let me give you an example on the result. As we said, the components of the result are the OK with the type and the error with the error, whatever the error is. And let's actually try the same function. So I'm going to get outside of the main function here. And we'll do function divide, and that's going to take, again, numerator with F64, denominator with F64, and it's going to return result with F64 type. And the second parameter is string. All right, so let's just close the curly braces. And here I want to check if the denominator is equal to 0. In that case, I want to return an error telling me that cannot divide by 0, and we're going to change that to a string format. And if that's not the case, I'm going to say else, and we're going to divide both numbers. Also, there is another curly brace here. So this is my divide function. Maybe I can change the name here. So divide result, and that's going to be divide option. So let's go ahead and try that. In that case, this divide here is going to be divide option. So let's go ahead and do match divide result. And that's going to take naturally the numerator and the denominator. So let's again take 10 point, or let's make it 100.23, 73.98. So now let's do OK, and that will take the result. So OK, result, and that's going to print ln. Result is, and whatever the result is. And also I want the error. It's going to return the error and the error with the error type. And here we want to print ln and whatever the error is. All right, so let's do it like that. Let's just organize it this way. And let's go ahead and try that. Just clear the terminal first and do cargo run. Okay, so we have returned here, we have returned 1.35. Okay, so it didn't panic and it returned a result. And if we will change that to 0, it's going to be the exact same, the same result as we have done with the option. So let's do cargo run again. And we'll have here the message, error cannot divide by 0. And that's everything I have for you guys in error handling techniques. Thank you so much for watching, and I will see you in the next part. Hello and welcome back to the last chapter in Rust Programming Language for Beginners course. In this last lesson, we are going to study the collection types in Rust: vectors, UTF-8, and hash maps. And let me start by showing you in the Rust book the collection types. And if you will see here, we have chapter 8 in the book, Common Collections, storing lists of values with vectors, storing UTF-8 encoded text with strings, and storing keys with associated values in hash maps. Now, what I don't understand, how Rust has put the common collections before the error handling. In my course, I've explained to you the error handling first, and after I explain the common collections. This is the correct way in my opinion. Alright, so let's go ahead and start with vectors and let's see what they have to say about vectors. So it says here that vectors allow you to store more than one value in a single data structure that puts all the values next to each other in memory. Vectors can only store values of the same type. And I remember that I shown you vectors in previous lesson. Anyway, if you want to create a vector, simply you will type the keyword vec, and you can see here that it's contiguous global array type, written vec, and in between those brackets, the letter T, short for vector. All right, so as I told you, it's mutable. You can, it's growable. You can push to it some elements and so on. All right, so if you want to initialize a vector, you will type vec like so with V capitalized with the annotation of new. New is a method. This simply tells Rust I want to create a new vector. And to make things more interesting, I want to create a variable and I will assign to it this vec. And you can see that Rust kind of complaining because since we're not inserting any values yet, Rust doesn't know what type of elements we intend to store. So, of course, unless we tell it explicitly. So we can do that here by doing like that. And that's going to be vec. And between those brackets, I will insert I32. And you will see immediately that Rust has stopped complaining. Just it's complaining here because it's not used. So to go around this, of course, we will add this underscore. But it's not a must. If you will run anything with the V like that, it will compile just fine. So I want you to think about vector as a cool dynamic array that can grow or shrink as needed. So when you call this vec new, what you have done here is that you have said, hey Rust, I want to make a new empty vector here. So more often you will start with some values in your vector. Actually, Rust provides a handy macro for this. It's called vec with the exclamation mark. And you can see that tab 9 even has started to insert those brackets here as a list, as an array. And we can have 1, 2, 3, for example, and we can assign this also to let the vec the vec, for example, something like that. All right, and that's going to be equal to vec, and let's also have type annotation vec i32. All right, I don't know why it's complaining, so should have snake case. Okay, because it's more than 2 words. You see, that's exactly the philosophy of, and that's exactly the philosophy of Rust. They like to get inside those small little details, but I don't know why they really care about the snake case or the kebab case or the camel case. I believe there is a reason for that. I'm not saying that there isn't, but for me, it's a bit, you know, getting inside the nerd snipping kind of thing. Nerd snipping. So they got inside the details itself, but solving the problem in a way, they don't really seem to concentrate on that more than they concentrate on these nuances of the snake case, the camel case, whatever. So this is a depiction of the nerd snipping. So there is a guy passing the road there, and 2 other fellows saying there is a certain type of brain that's easily disabled. If you show it an interesting problem, it involuntarily drops everything else to work on it. So yeah, they gave him this problem, and he started to, you see, it's interesting. Maybe if you start with no, wait, you could, you see. So he's talking too much, and unfortunately he got kicked by the car. So that's the problem. You get, you know, caught up with the details and not concentrating on the problems itself. I feel it's the same thing here with the camel case and stuff. So again, be careful that the vector should be, you know, has this type annotation vec, and between those brackets, those angular brackets, the type itself, i16, i8, i32, u32, whatever. If you'll do only i32 here, it's going to complain, right? Because it says here that mismatch types, expected type i32, because you've defined it here i32. However, you've given him this macro vec with the underscore. However, you have given him this vec with the exclamation mark macro, right? So you need to be careful about that. So let's say you want to add elements to your vector, okay? You can do this using the push method. It's like in JavaScript, in Python, you know, append, push, you know, those methods that they can push something into an array. If you want to push to this, the numbers vec, what you will do is you will take the numbers vec dot push, and you will push 5, for example, right? You can push other numbers if you want. You can do 6, 7, you can do 7, 8, 9, all right? But by the way, we will need to have the same name. Okay, so let's keep it V, right? Because basically I've initialized it, then after I created this vector, and then after I'm going to push inside that vector. So for consistency and for functionality, because otherwise it will not work. And you can do this with strings, with booleans. The most important thing is that your vector should have homogeneous type of elements. Let's print, let's see what we'll have, print ln, and that's going to be the vector. That's fine. So let me do cargo run. All right, 5, 6, 7, 8, 9. That's odd because it should. All right, I see what's happening here. So that's not mutable, and we have created this as mutable, right? So what you will have to do is just making like that. All right, this is complaining, and I will change this to be mutable as well. So this should print no problem. First we have initialized, next we have created this vector, and after we have pushed all that. So let's see what we'll have. We should have 1, 2, 3 till 9. Yep. So vectors really are awesome. And what's more awesome is how you can read elements of vectors. So let me show you what I mean. If we have, let me actually comment all of those lines out. And let's just shut that. Let's have this again, vector. I have like this from 1, 2, 3, 4, 5. Yeah, that's enough. And let's have the third element. I want to print basically the third element. This is going to go through indexing. Not only, but we can have another method called get. So I'm going to explain that now. We can actually return any element inside by indexing. So we have zero index based system in programming in general. So you have to go by zero. That's going to be zero index for element 1, the first index with element 2, the second index with element 3, and so on. So if I want to return the third element, that's going to be index number 2. Let's go ahead and try to do that together. So let's say that this variable is called third, and that's going to be of data type i32. But not only i32, it's going to be reference to i32. Why reference? Because I don't want to take the ownership of the v, right? The underscore v. So that's exactly what I want to do. I want to initialize this variable. This variable is of data type i32 as a reference and is equal to reference to the underscore v with the second index, which is going to be equal to number 3 in the vector. All right, so that's through direct indexing. And if you will try to print that out, we can say here, the third element is, you pass here third. All right, so let's go ahead and try that out. We should get 3, cargo run. So because the second index is number 3. And bingo, the third element is 3. Good. Now there is another way to return elements of a vector or read elements from a vector. This is using a get method. So again, I'm going to declare another variable. And I'm going to call it third again. And that's going to be equal to underscore v dot get. This get method basically gets whatever index you want from the vector. Right, so that's really handy. Just underscore v, that's our variable, and you're going to get the second index. And you can see that it just, inserted whatever. Index equal to 2, and option, we have studied it in the last lesson, error handling. Option returns none or some. None if it doesn't return anything, and some if it returns a positive result. And we're going to match third, exactly that. So we said that sum, and it will return third of reference for the i32, and we have printed the third element. None, we will say that there is no third element. Okay, let's do like this, and let me actually do like that. All right. Let's do cargo run again. And again, bingo, the third element is 3. Let me maybe change the message. The third element from a get method is whatever. So we can change even the index to be 4, for example. So that's going to be 0, 1, 2, 3, 4. So it's going to be number 5. All right, let's see that. And bingo, the third element for a get method is 5. And that's it for vectors. That's everything that I have for you guys. Next, we're going to see the UTF-8 encoding. All right, guys, so let's check out again the book and what it has to say about the UTF. So the UTF-8 is all about strings. So storing UTF-8 encoded text with strings. I'm not sure if I have a lot to tell you in this, but strings in Rust is very important. So if you read here, it says we will first define what we mean by the term string. So you know that string is a chain of characters, right? It says here that Rust has only one string type in the core language, which is the string slice. If you remember when we have studied the primitive data types the first lesson, we have shown the difference between a string and string slice. So string slice is usually seen in its borrowed form and stir. That's right. And it says here that in chapter 4 we talked about string slices, which are references to some UTF-8 encoded string data stored elsewhere. String literals are stored in the program's binary and are therefore string slices. Now the string type is provided by Rust standard library. rather than coded into the core language. So you have the string slice, it's a reference to a string that you have written it or encoded it by hand. However, the string type itself, when you will do string and then the double colons from, and you will have inside parentheses, inside double quotation, and the word or the phrase that you want, right? This is the string. This string actually is growable, mutable, owned UTF-8 encoded. You can see down here that to create a new string, you can, define or declare a variable, a mutable variable that's going to be of data type string with capitalized S with the double columns and new method or new macro. This tells us simply, hey, I want to create a new string called S. Now you have to remember that strings are UTF-8 encoded. So it says here we include any properly encoded data in them as shown in listing 814. You can see that different characters. Arabic, Dobry din, I think it's Czech. In Japanese, konnichiwa. In Russian, здравствуйте. So all of these are valid string values. If you happen to create your application or your website or whatever, and you have to insert those UTF-8 encoded strings, that's going to be absolutely fine. Rust is not going to complain. Let's have this let s equal to whatever, right? And we'll do here, and then we'll convert that to string. And we'll say here, let s equal to string from whatever. Make that as mutable. So that's going to be string from foo, for example. So that was the first way. That was the second. And here I'm going to mutate the variable, like push to it. So now if I want to take that s, I want to push to it bar, for instance. So I will not do push like that. I will push string. And the difference here is that we are pushing a string slice and not character. All right. So push stir, and we are going to say bar. If I want to insert one character only, I can do s push, and we can do like this. So first I'm going to just make like that. Let me actually print this. So let's print ln, the value and we'll keep it like that. All right. Let's do cargo run. All right, so the value of s is equal to foo bar. It's complaining here because we don't need the double quotation mark. We need only single. So that's for the character. All right, so be careful that push is only for one character, push underscore stir for a string slice. Now let's do cargo run. And we will have the value of s equal to foo bar with the exclamation mark because we've pushed it to the string. For instance, if you want to combine, you can do so by the plus operator. We can have this, for instance, s1 is a string, and that's going to be hello, and s2 is world. s3 is equal to s1, so it took the ownership of s1. This s1 doesn't exist anymore. Plus, it takes the reference to s2. This is, by the way, from the book, okay? So concatenation with the plus operator or the format macro. Note that s1 has been moved here and can no longer be used. And that's basically because we cannot add two owned values or two owned variables, okay? So you can see here that the string s3 will contain hello world. That's absolutely expected. The reason s1 is no longer valid after the addition, and the reason we used a reference to s2 has to do with the signature of the method that's called when we use the plus operator. Plus operator uses the add method, whose signature looks something like this. So this is the addition. Self is the owned variable, And the other or the second parameter is a string slice, a reference to a variable. All right. So we should add a borrowed and a reference. So you can read all of this. Very important to understand, guys. I'm not going to explain every little thing. It's very important to read as well. Don't take the source of information only from me. You need to do your homework. You need to read and understand. Now, if you will print ln, we can say here the value of S3 is whatever the S3 is. If we'll do cargo run, we can find here that the value of 3 is equal to hello world. As far as the formatting strings, by the way, this is not entirely true because I need to put this here and this here like so. If I'm not mistaken, I don't want to look to the book too much, but if I will do print ln and I will print full message, right, I will get an error. Let's see the error. Format argument must be string literal. So yeah, we can do like this. And let's print that. Let's cargo run that. Okay, so we got the expected answer, except that the Arabic is really destroyed. Let's try with Russian. Let's try, there was Здравствуйте here. Yeah, let's take that. Let's put it here. Oops. Let's put it here. Let's run that again. Okay, it went better with Russian than with Arabic. Alright guys, so that's the end of UTF-8. Strings in Rust are really powerful and safe, so automatically ensuring valid UTF-8 encoding. Alright, this is the last chapter of the last chapter, if that makes sense at all. This is storing keys with associated values in hash maps, the last element in common collection types in our Rust course. So it says here that the type hash map, it takes two arguments, k and v, stores a mapping of keys of type k to values of type v using a hashing function, which determines how it places these keys and values into memory. And many programming languages support this kind of data structure, but they often use different names such as hash, map, object, hash table, dictionary, and associative array. All right. Python, for example, we have a dictionary. In JavaScript, we have object. In other programming languages, you can find hash, you can find map, and so on. So to create a hash map, you will enter the keyword hash map like we have done with vector before. And you will assign that to a variable called scores, and that's going to be a mutable variable. Now, if you want to insert inside that scores hash map, you can do that by insert method, and then you will have string data type, and then you will have the type annotation string from blue. That's going to take 10 as the second parameter. Now, there's something missing here, which is use standard collections hash map. Note that we need to first use the hash map from the collections portion of the standard library. And as you can see, we have a variable called team name, and that's going to be string from blue. Also, I can have the score. So if I will do let score equal to the scores hash map dot get, in this method, we'll get a reference to the team name. So exactly dot not unwrap dot copied dot unwrap or 0, and copied I forgot to call the method. All right, so if I will say for key value in n scores, I want to print ln, we're going to print out each key and the corresponding value. So we'll say key. Yeah, we can do like that, or simply you can take the key, you can insert it here. You can do the same with the value. You can insert it here, and you get rid of those two commas like that. And there is a missing curly brace. There we go. All right, if we will do cargo run, we will have blue 10, yellow 50, because we have iterated over the hash map. This is just to give you the gist of hash maps, But I can tell you something very interesting. Rust by default uses a very secure hashing algorithm to protect against the DOS attacks, or the denial of service attacks. It's a kind of attack that is very common where hackers actually use it to attack some websites by sending like flooding this website with millions of requests just to make that website shut down. Alright guys, this is the end of this course. Thank you so much for watching. I hope this course was useful to you and opened your senses to start creating your own Rust applications. It was a long journey, and I hope to see you in more advanced Rust videos, whether continuing into more advanced concepts or creating cool projects. Keep coding, keep learning, and I will see you in the next course. Till then, stay safe and be well. Take it easy, guys.